Welcome to our deep dive into the Boyce normal form, or BCNF, and how it's essential for eliminating redundancy in database design. We'll start by establishing the core concept that BCNF addresses: functional dependence. Functional dependence is when a column A depends on column B, meaning each value of B is related to, at most, one value of A. We denote this relationship as B determines A, or B right-pointing arrow A. In this context, the columns A and B can be either simple, meaning a single attribute, or composite, meaning two or more attributes grouped together. Functional dependence applies regardless of which type of column is used. Now that we understand functional dependence, let's look at the problem BCNF solves: data redundancy. Redundancy is created when a column depends on another column that is not unique. This is problematic because it causes repeated data across the database, leading to inefficiency and potential inconsistencies. If a non-unique column determines another, the dependent data must be repeated for every instance of the determining value, causing unnecessary bulk and maintenance headaches. This brings us to the core solution: the Boyce normal form principle. BCNF dictates that all functional dependencies must be on unique columns. This is a fundamental rule for maintaining a healthy and efficient database structure. Dependence on a unique column ensures that the dependent data appears only once, thereby eliminating the redundancy problem altogether. Let's look at the process of how BCNF actually eliminates this redundancy. By applying BCNF, the messy, redundant table is decomposed into smaller, normalized tables, each with a clear primary key and efficient structure. These normalized tables are then linked back together using foreign keys, maintaining the necessary relationships without introducing any functional dependence-based redundancy. In conclusion, BCNF is more than just a rule. It's a foundation for solid database design. Boyce normal form is a powerful design principle that leads to efficient and maintainable databases by structuring data correctly. It ensures reliability by guaranteeing that functional dependencies never introduce redundancy, keeping your data clean, efficient, and accurate. Remember, BCNF, redundancy eliminated.
So let's look into redundancy and dependence. And on this table, we have the passenger number, then it goes to passenger name. This is a table about booking. Okay, so we have the flight code, the fare class, the boarding zone number. So since the passenger number is always identify the same number, passenger number depends on the passenger name depends on the passenger number. Okay, because why? The passenger name depends on the passenger number because a passenger is identified by the name. Good? Right. So let's get to the next. So since a passenger may have bookings on several flights, passenger number is not unique. As you can see, Elvira Yin has booked several flights with the same passenger number. So the passenger number is not unique. All right. So the dependence of passenger name on a non-unique column creates redundancy, right? Good. Now that we have the idea, we can go on and now start working on this activity. So what does boarding zone number depend on? Let's check the boarding zone number. Okay, so we have the fare class and we have the flight code. So if you're sitting in a specific zone, then I think that relates to the class in which you'll be sitting. Let's try. So we start with C, fare class. That's correct. Dependencies are based on business rules and cannot be confirmed by table data alone. However, the table data suggests that boarding zone number depends on fare class. Okay, why is it not flight code? Because flight GC848 has a different boarding zone for different passengers. So boarding zone number does not depend on flight code. Let's see. So we have flight GC848 and it's here. So it has different passenger number, right? All right, let's see why is not passenger name. Because Alberta has different boarding zone on different flight. So boarding zone number does not depend on passenger's name. Let's see. So we have Alberta here with a different passenger number, boarding different types of flights. That is flight 1, flight 2, flight 3, and different class, first, economy, and business, right? So is fare class unique? Let's look at fare class. You see, we have fare class Elvira Yin being in first, economy, and business, and the same person. So is it unique? In my opinion, I'll say no. Let's see. Correct. Okay, remember this, that was fare class. So in my opinion, I'll say no, because fare class contain repeated value first, and therefore it's not unique. So we cannot say yes because it contains repeated value first, therefore it's not unique. And we cannot say we cannot determine from the table because we can determine from the table. Okay. So does the dependency fare class boarding zone number create redundancy? Let's see. Does boarding zone number create redundancy? I'll say yes, because we have Deepak Chopra with 1 and Mary Hatcher with 1 and Elvira Yin with 1. So I'll say yes. Let's see if we can. I went wrong or right. You can put it in the comments. Yes, yeah, because first class equals to boarding zone number is a dependency on non-unique column. So such dependency may create redundancy. Redundancy appears as a repetition of first one in the first class boarding zone number. Yeah, let's see this. There's a repetition in first, that is 1, okay, and that is, you have fare class and boarding zone number. So if you're looking at first class, fare class, and boarding zone number, you can see a repetition. So that tells you that there is redundancy. So a table with a dependency not on a non-unique column dash contains redundant data. So a table with dependency on a non-unique column, always or often or never. I don't know. Let's try. Always is incorrect because dependency on a non-unique column allows for redundancy. However, a table with such a dependency may not have redundant data all the time, particularly if the table has few rows, right? So never say never, because dependency on a unique column allows for redundancy. So redundant data usually appears as more rows are inserted or updated. So the correct English is often, because dependency on a non-unique column allows for redundancy. So redundant data usually appears as more rows are inserted and updated.